Okay, so we're continuing on the quiz. This is number 5 from the quiz that you took yesterday on February 11th. So it says, how many grams of this compound are present in 33 moles of it's the same compound? So it must show all your work. We're just converting here. Okay, so it's whatever you have in here, which is 33 moles. That's what you were given. So if this is moles here, this is going to be moles. And then whatever we're looking for goes in the top right. And in the beginning of the question it says how many grams. So we're looking for grams of the KO3H42. Where are we going to find that grams, or what number do we put there? Yeah, you got to find the mass. You have to look up that entire compound on the periodic table. So there's 1 K, there's 3 oxygens, there's 4 hydrogens. Oh, no, but then there's this too. There's 6 oxygens, and there's 8 hydrogens. Okay, so the K is easy, 30.098. Hydrogen is 1.008 times 8, because there's 8 hydrogens. And oxygen times 6. Okay, so right now I'm just finding the mass. I'm adding all these units together. It's 15.99 times 6. 95.94. So these 3 values, all you do is add them up so you can get the total weight of that compound. $134. That's the number I got when I added them all together. Now what I'm going to do is, these 2 numbers are side by side, so they're going to get multiplied. Okay, what number do I put in front of mole? 1. This is still the mole concept. Earlier I said the difference between if we're using coefficients or we're just using the number 1. You're going to use coefficients if you have an actual equation at top. Okay, but we didn't have one, so that's a dead giveaway that this is just where you put a 1. So go ahead and multiply those 2 numbers. And your final answer for this question should have been and that's in grams. 4,425.37 grams. Number 6, what is the percent composition of that giant molecule? Okay, so we have to get the percent composition of every single element that's in that. So for K, for C, for H, for O. But before we can do that, just like on an exam, if you're finding your percent, the formula, try to remember, is part over total times 100. That's how you get a percent. Okay, so step 1 is to find the entire mass of that compound because we need the total. We need to find the total. So again, this is just adding. That gives me 1K, 12 C's, 24 H's, 6 oxygens. Carbon weighs 15.99. I'm going to multiply it though by 12. That's 191. Hydrogen is 1.008 times 24. Oxygen's 15.99 times 6. To get a total, I add them all together. The total mass, so my denominator, is 342.11. Yes.
Carbon is wrong.
It is? Okay. So carbon is 12.011 times 12. Is it that the right number of atoms though? 12? Oh, you're right. It should be 144.32. Okay, let's get a total again. I'm going to add them all together. So my total is 294.4. Okay, somewhere around that. Now let's do this part divided by whole. What does that mean for each one? So for K, K's mass was 30.098. Divided by the total. Times 100. That's going to give me a percent. Okay, and you do that for every single one. Okay, I'm just going to do these first two and you see the pattern. You'll do it with every single element. So we should have 1, 2, 3, 4. We should have 4 percentages. So for potassium, 30.098 divided by 294.4 equals times 100, 10.22%. If you just put 10.2, that's fine. 10.2%, percent signs kind of squashed. This one, 144.32. Equals 49.02% of carbon. And again, you would do that for every single one. So that's your percent composition, that's how much potassium's in there, and then that's how much carbon is in there. And you would do the same exact thing for hydrogen and for oxygen. We're going to move on to number 7. Any questions on that one? On number 7. The empirical formula for a compound shows the symbols of elements with subscripts indicating the what? The correct answer is D, smallest whole number ratio. Okay, the smallest whole number. The empirical always looks reduced. Looks like it cannot be reduced any further. Okay, let's jump to the back. This one was a little tricky. There's a gold coin. It says it has, I'm just going to underline the important words, 10.31 grams of gold. Calculate the number of gold atoms. So it's given grams, I need atoms. And then this was supposed to be removed. Because you were my first class, I'm not sure I told you that. But let me just show you how to work it out, and I'll throw this question out for this period, for period 3. The same thing goes, what I was given. And I want atoms. So if you can set up your T-charts, like the units, and label them, then you can plug in numbers. It tells me what the mass of gold is. They were nice about it. Typically you'd find it on the periodic table. The grams, where do we go for grams? We look to the periodic table. Atoms, what number do we use when we're looking for atoms, molecules? Avogadro. Multiply across, divide by the bottom. Excuse me. 10.31 times Avogadro's number. Okay, when I multiply across, I got, and then I'm going to divide by, your final answer for this is and I did that just by dividing these two numbers. Okay, let's get to number 9. The molecular formula, so they gave us the molecular formula. What is the empirical formula? Okay.
Can't you just do this without doing any work?
Yes, what do you think it is?